In this video, I'll be discussing lag compensation of shots in a game that uses prediction. You'll want to have watched the videos on entity interpolation as well as the ones on prediction before this, as this lag compensation is built on top of all of those. I'll be working with the code from the Nengi Beta 3 shooter of lag compensation. I always say that client-side prediction is simple conceptually. You basically take your input, simulate it on the client, send it to the server, and simulate it on the server. And I say that's simple conceptually, but difficult to actually accomplish. Lag compensation of shots, on the other hand, is something that sounds complicated conceptually, but is pretty simple to actually accomplish in code. The main idea here is that when you fire your weapon in the game, and you have latency, by the time the server hears that you've shot, the objects you're firing at may have moved on to another position. But mathematically, there's a way to compensate for that. Before I get into that, let me open a couple clients here and let them blast each other a little. So here I am on one computer shooting the other. This server's in New York, I'm in Seattle. Once again, let me turn on this little packet dropper thing that I enjoy. Actually, latency, adding 250 milliseconds of lag. I'm going to reconnect them because Nengi calculates its ping rate when you connect. I mean, it recalculates it over time, but just to keep it accurate. Reconnecting. So, my movement via prediction, I'm playing this white character here on the left screen, is fast. You can see my lag if you look a little bit on that other screen. It's right a little bit behind me because I have 250 milliseconds plus whatever my actual ping is to the East Coast. So you can see that. You can see my position is a bit delayed. Now, while moving, I'm going to try and shoot this character over here. Now, if my lag isn't not my lag, if my aim isn't horrible, I can do it. Now you'll notice that my predicted shots are traveling right through it. And I'm getting hits, but I don't see its hit points drop till later. Why is that? Well, I've written prediction for the shooting. I've written prediction for the movement. I haven't written prediction for doing damage. Why? I think it's inappropriate to write prediction for doing damage. Can you really predict that you did damage? I think that's something you should let the lag show and let the server authoritatively say whether you did damage. That is a bit of a gray area. Perhaps you could show yourself doing damage, but you really should rely on the server's authority in the end. You certainly shouldn't predict yourself having gotten a kill on somebody. If you're lowering their hit point bar, it should be purely aesthetic. Now, something I can't quite show you is I can't move both these characters. It's just physically impossible. I mean, I could write bots to do it. But the real best lag test here would be to get one of your friends, load up this thing, rent a server, publish it on the server, run these lag programs, and then blast each other. Then you could see the lag for real. You could also see the hit prediction or hit compensation trying to do its best. But let's go read the code. So conceptually what we do, actually what Nengi does. Nengi makes snapshots and it sends them out every frame. It's part of its magic. We get all kinds of determinism and all kinds of fancy things by virtue of building upon this. One of the things we get is a concept of a history. In Nengi, in the instance, is something called the historian. The historian stores some data, minimal data, very minimal data, just positional data, about where entities are every frame. And it deletes it after a little while. I forget what it's tuned to exactly, but it's something like 20 frames or 50 frames. And what we get from it is that we can ask Nengi where something was in the past. And we do this when we fire this ray in this game. When we shoot this ray in this game, we realize that a fire command has been issued by a client. We check if the client's, weapon system is off a cooldown, and we check, the game log to make sure they're allowed to fire. Then we begin to dig into the history. What we do is we figure out how long ago this shot was issued from the client. Now, how do we know? Well, we know the client's latency. It's part of Nengi. It's been recording it. It's in this, not so beautifully named variable called latency record average latency. We also know the client's interpolation delay, how long it spends interpolating, because we programmed that in there explicitly. It's 100 milliseconds. If we add its latency and its interpolation delay, then we know at the time that we receive an input from the client, we know how old this input is. It's those two numbers added together. And because we have the historian, we can ask the Nengi historian, what was the state of the game, 350 milliseconds ago, for example. If we then, rather than do a, hit scan check on where the entity is currently aiming and shooting, if we instead do a hit scan check on where the state of the world 350 milliseconds ago, we will be performing a hit check on a state of the game that resembles the screen that the player saw at the moment that they shot. Sounds like a miracle, right? So that's the beauty of lag compensation. Conceptually, or lag compensated shots and collisions. Conceptually, a bit of a stretch. Programmatically, if you've got a history, if you've got snapshots, if you know their latency, it's sort of a freebie. So how do we do it? Well, you use this Nengi function, instance historian get lag compensated area. You pass to it how long ago you want compensated, in this case, latency plus interp delay. And then you create an axis aligned bounding box for the area of the world you want compensated. This works via spatial structure, or rather it could. I gotta admit, it uses brute force at the moment, but you're allowed to change the spatial structures that are in Nengi score. And then it returns to you all of the entities that are in that square at that point in time in the past. Then you just do your hit logic as normal. For this particular game, this game works with SAT collision library. That's just kind of a shapes colliding with shapes kind of collision library. And I take, another thing worth mentioning about the historian is it's not storing real entities, it's storing just little proxy entities. It's just their X and Y. So I look into history, I move the collider to where it was at that point in time, I run my collision logic real quick, see if it was a hit, then I restore the collider back to its current position, and I invoke this function called onHit if it got a hit, and then my hit logic follows. In this case, take damage, they do 25 per hit, after 4 hits they're dead. So there's lag compensation in Nengi. It's a freebie. It comes by virtue of having snapshots, having latency. It's a great feature. You will find that it is not without flaws, though. Some of its flaws include that the time that we're trying to guess about how long ago a shot occurred from the server is only as consistent as someone's latency is. If you run that query, if you will, that spatial query against the past state of things, right as somebody is experiencing packet loss or a lag patch, it's not quite going to line up. It's still a hell of a lot better than what normally happens with a laggy player playing a game without the system in place, which is that against objects that are moving any decent speed at all, they will literally never land a hit by firing at something where they see it, unless it's moving straight toward them or straight away from them. Because if it's moving even slightly off to the side, their shot is no longer going to be on it. In the next tutorial, I will talk about the advanced features of compensating for packet loss and low frame rate players.